let's look at a few examples of how we would use the substitution method. So here we have an integral, and we notice that if we let u be what's inside the radical here, then du is almost what's on the outside. So let's look here. We're going to let u equal x squared plus 3. And then, of course, du then would equal 2x dx. Now, this 2x dx is almost what we have on the outside, but really what we have is x dx. This 2 is extra. So look, here's what we can do. We can just divide by the 2. See, I just divide by the 2, and now x dx. Here's x dx. I can replace that with du over 2. So now let's see what we have now. We have the integral of the square root of u, and then in place of x dx, I'll put du over 2. There we have it. Now, if I factor out that 1/2, I get the integral of u to the 1/2 du. I did 2 steps in one here. I factored out the 1/2 and I converted the square root of u to the 1/2. Now, it's easy for us to evaluate this because we've got the 1/2, and I'll just leave that where it is. But now I've got 1 over 1/2 plus 1, u to the 1/2 plus 1, plus c. And let's see what that gives us. This gives us 1/2 times 1 over 3/2, u to the 3/2, plus c. Yeah, there we go. And a little more simplifying. We're going to have 1/2 times 1 divided by 3/2 is 2/3. So that would give us, the 2's would cancel here, and that would give us 1/3 u to the 3/2 plus c. There it is. And you can go back and substitute back in if you like. We could go back in if we wanted to and say, well, this is 1/3 x squared plus 3 to the 3/2. We could do that if we wanted. Okay, so there's an example where, you know, we had to do a little bit of extra, because when we found du, it wasn't exactly what was on the outside. Okay, let's look at another one here. Let's suppose that down here we've got, let's say x squared plus 5x plus 6. And up here we've got 2x plus 5. Okay. Now, notice that if we let u equal the bottom, then du is the top. See, 2x plus 5 dx. There we have it. So now we can plug back in here. And let's see what we have. In place of 2x plus 5 dx, I'll just put du. And then we've got u on the bottom. So that's just going to be the natural log absolute value of u plus c. There we have it. And that is our antiderivative. And we could always plug back in if we wanted to. But that's all we need to do. Now let's look at another one here. Let's suppose that we've got cotangent. And we want to evaluate that using substitution. Now you might look at that and think, well, my goodness, I don't see any way to use substitution on that one. Well, let's remember our trig identities and look upon this as cosine x over sine x. Well, now, look, if I let u be sine, I'm on my way. Because look, So because I know the derivative of sine is cosine, so I'm just going to let u equal sine x. Then du is cosine x dx. Okay, now let's see what we've got. Let's see what that looks like. In place of cosine x dx, I'm just going to put du. And in place of sine x, I'll just put u. And now notice what we have. We have the natural log absolute value of u plus c. There we have it. Now, remember, if we want to, we can go back and put that in, and we can substitute back in and say, well, this is the natural log of the absolute value of sine x plus c. We could do that if we wanted to, but there's no need to. So these are just some examples of how we can use substitution